With the emerge of driverless cars, the navigation through an unexplored maze is an interesting case study of an intelligent mechatronic system. In order to get information about the environment, the robot is equipped with 4 sensors and 2 actuators. A color sensor is used to detect a red surface. This means the end of the maze is reached. The robot has one rear wheel to minimize the slip. A gyro sensor is used as feedback in the turns to the left and the right. There are 2 ultrasonic sensors in total. The behavior of the robot is mainly dependent from the one on the right. The steering mechanism consists of a small motor, from which the rotation to the front wheels is converted using a pair of gears. Finally, the second ultrasonic sensor checks the distance in front of the robot. Our overall maze-solving strategy is to always follow the right wall. The control mechanism of the robot is based on a subsumption architecture, which is a reactive robotic architecture that divides the complex robot navigation into several different vertical subtasks, called behaviors. The arbitrator class is used as a behavior control system, so that always the highest priority behavior is running and the others are suppressed. From highest to lowest priority, these behaviors are red surface reached, drive backwards, turn right, turn left, and drive forward.
The color sensor has the highest priority. When the color sensor detects a red surface, the driving motor is stopped and the system is interrupted. The emergency brake behavior takes control when one of the following criteria is met. The first one is when the distance to the right wall is very small. The robot goes backwards while turning his wheels 20 degrees and then goes forward again. In a dead alley, the robot will first move backwards while rotating its wheels, then the robot goes forward while turning left.
The turning right behavior becomes active when the ultrasonic sensor on the right measures a distance bigger than 50 centimeters. This is the only criterion needed for this behavior to become active, and is very important for our chosen strategy, which says, always go right if possible. The turning left behavior has the second lowest priority. When the robot encounters a wall in front, it will only move to the left when the measured distance at the right is smaller than 50 centimeters. The action method works in the same principle as the turn right behavior, namely with the help of a gyro sensor. The drive forward behavior has the lowest priority and is thus always active when it's not interrupted by any of the other behaviors. For keeping the distance to the right wall at a constant level, a PID controller is implemented. The speed depends on the distance in front of the robot. When approaching a wall, the speed gradually diminishes. In this way, maneuvers are done at a low speed.
In order to improve the overall robot behavior, learning from previous runs through the maze could make it possible to avoid some dead alleys and reach the end of the maze faster. As using exact coordinates in the maze would not be accurate enough, the navigation part is saved by chronologically storing all executed behaviors, except the default drive forward behavior, as a character in a string. When the robot reaches the end of the maze, the string is analyzed to encounter the first dead alley which could be avoided and to find at which right turn this dead alley did start. This position is stored in a text file on the brick. At the next start of the program, the positions where turning right has to be suppressed are read from the text file and stored in an array. If the robot reaches such a position, the robot drives forward until the end of the right aisle, and then the normal strategy takes over again.